Today is the lovely 9th of December. You have 10 more school days to see my lovely face. So, Christmas. It might have been. Okay, so 8.3. Somebody tell me without dividing how I would solve this equation. You would multiply by a third, which is called its multiplicative inverse. When I do so, 1/3 times 3 gives me my multiplicative identity, which is 1. Right? If I times anything by 1, I get the same thing, correct? Okay, but what I do to one side, I do to the other, right? And x equals 3. Do we show our multiplicative identity here? Can we? Sure. So, you might be asking, Mr. Roberts, how does this relate? Okay, well, I'm going to start you off. Notice number 3's Bell quiz. If you'll recall, the answer to that solution was 29/7 and 10/7. Remember that for just a minute, okay? What I'm going to do first is find this guy's multiplicative inverse. Okay, and I'm going to show you how. There's an easy way and a hard way, and both ways are on your test. Okay? So, the first way is called using the augmented inverse. That's how you're going to do it. Because what you do is you put the coefficient and you attach it to its multiplicative identity. Does anybody remember the multiplicative identity from the very first day we started this unit? 1, 0, 0, 1. Excellent job. Okay? That is the multiplicative identity. You attach it. And then what you do, ladies and gentlemen, is on the left-hand side, you complete reduced row echelon form. So basically what that means is this stuff's going to move over to here, and we're going to do some stuff, and that gets us values on this side. Okay? This is the hard way. Okay? By the way, when you do inverses, I will never ask you to do an inverse of a 3x3 or higher. In our core, it only says we have to do 2x2s by hand. Okay? So on your homework, if there's any time you have a 3x3 or higher, use your calculator, and I will show you how to do that later. But if it's a 2x2, you might want to do it both ways and using your calculator. One time using one method, one time using another method, okay? Does that make sense? Because on your test, I will ask you different ways. Okay, so once again, ladies and gentlemen, we're going to get the reduced row echelon form on the left-hand side. So I want a 1 there. Hot dog, we got 1. What do I want? A 0. So this guy is 5, -2. Everybody see that? Keep the top row. So then notice -2 plus 2 is 0. -7. -2, 1. Anybody have a question there? Yes, no, maybe so. All I did was basically do what I would do to solve, right? Okay, I want this guy to be a what? What do I do whenever I want a 1? I multiply or divide. So in this case, I am going to divide. Can you see? Ready? Yeah. 1, 2, 1, 0, 0, 1, 2 sevenths, -1 7. Anybody have a question so far? There you go, Sam. Better? Not as low. Okay, is that in reduced row echelon form? That's in row echelon form, right? What's the difference between reduced row and row echelon? This 2 becomes a 0, right? So how am I going to get him a 0? I'm going to multiply the bottom row by what? -2. So this becomes 0, -2, -4 sevenths. By the way, the 1 is a 7 seventh. -2, that becomes a 2 sevenths. Anybody have a question there? Yes, no, maybe so. Okay, I add them together. 1 plus 0 is 1. 2 minus 2 is 0. 7 sevenths minus 4 sevenths 3/7. 0 plus 2/7. 2/7. And notice I have, ladies and gentlemen, this matrix right here is the inverse. So 3/7 times, 2/7, 2/7, and negative 1/7 is the inverse of the original one we started with. Now, what does this help us do? That's maybe what you're asking.
It's not, but
Go ahead.
okay, just when you put the 0 on the top row, can you explain that one more time why?
So why I get a 0 right here?
Yeah.
It's because I'm in reduced row echelon form. Remember, reduced row echelon form is 1s down the diagonal and 0s everywhere else.
Oh, okay. Okay.
So in our case, with a 2x2, 1s down the diagonal and 0s here. So you still do the same pattern, 1, 0, 1, and then come back up.
Okay.
Okay?
Thank you.
Does that answer everybody's questions? Is everybody okay with that? Now, you might be asking, Mr. Roberts, what the heck does this do? Well, I'm going to go ahead and write this really quick. 1, 2, 2, negative 3. If I multiply these things, what do you guys think I'm going to get? I'm not going to get 1. I'm going to get the matrix multiplicative identity. For our case, it would be 1, 0, 0, 1, right? That's what we should get. Should we show? Here we go. Row by column, correct? 1 times 3/7. 2 times 2/7. 4/7. 4/7 plus 3/7 is 7/7, which is 1. 1 times 2/7. 2/7. 2/7 times negative 1/7. Negative 2/7. Add those together. 0. 2 times 3/7. 6/7. Negative 3 times 2/7. Negative 6/7. Add those together, you get 0. 2 times 2/7 is 4/7. Negative 3 times negative 1/7 is 3/7. 4/7 plus 3/7 is 1. That proves they are inverses. So on the test, if I say, are these two matrices inverses, what would you do? You'd multiply them together to see if it comes out into the matrix identity for multiplication. Remember, matrix multiplication identities have to be square matrices with 1s down the diagonal and 0s everywhere else. So if it was a 2x3, can you have an inverse of a 2x3? No. You can only have inverses of square matrices. I want to write that down. You can only have inverses of square matrices. Joshua, are you still cold? Yeah. Coming from India? India? Yeah, bloody hot spot. Okay, watch this now. Okay. So, question. Remember how the other day I asked you if matrix multiplication was commutative? And what was our answer? The only time it is when they're inverses. Just notice, watch me if I'm inverses. Ready? Okay, take these guys to this guy, and I'll just show you two of them, and that pretty much proves it. 3/7 times 1, 3/7. 2/7 times 2, 4/7. 3/7 plus 4/7 is 3/7 times 2, 6/7. 2/7 times negative 3, negative 6/7. You guys see it's going to come out? Okay? That's the only time it is commutative, is when they are inverses. Okay? When they are inverses, it will come out to be the same answer. Okay? All right, now you might be asking, well, Mr. Roberts, why is this useful? Why are we doing inverses? Well, so coming back, actually, to problem number 3 of the Bell quiz, can somebody write that as an equation again for me instead of as an augmented matrix? Does everybody understand how to go from an augmented matrix back to the matrix, the equations of themselves, right, with variables? Okay, you guys remember the very first thing I showed you is what a matrix can do by ordering information in a certain way, right? Well, you guys remember what that was called? It was called a matrix equation, wasn't it? And notice it looked like this, where I had my coefficient matrix, my variable, and then my solution. Oops. Okay? Doesn't that look like, basically, we have a matrix times some variables equals an answer. Right? Let me just prove to you first off that this stuff equals that. How do we multiply a 2 by 2 by a 2 by 1? We take its rows by columns, right? Notice that was the first row, first column, so I should be in the first row, first column, which is right here. 1 times x, x. 2 times y, 2y. What do we do to those? Add them. So x plus 2y equals 7. That's why it works. 2x minus 3y. Add them together is 2x minus 3y, and it should equal 4. Came right there to there, right? Okay, now once again, can we divide matrices? No, that's why we have to find inverses. Okay, once again, what was the inverse of this guy? It was 3/7. That color sucks, but too bad. And we've already proved that when we multiply to this, what do we get? We get our identity matrix, but when I go ahead and multiply by a third, do I leave 1 there? No. When I multiply this, yeah, I'll have x, y, but what's left in front of it technically? 1, 0, 0, 1, but am I going to write that? No, I'm not, right? Because it's like the identity, we leave it alone. But what I do to one side, I got to do to the other. So let me ask you, so I'm going to call this guy A. So what's this guy called? A's inverse. Does that make sense? Now, here's the question. Where do I put A's inverse? Do I put it in the front or the back? Because, once again, is multiplication commutative. So, notice that is a 2 by 2. So this is a 2 by 2 in front by a 2 by 1. Or can the 2 by 2 go in back? Where does it have to go? In front, because once again, when we multiply, the innermost has to be the same, right? Does that prove why we have to do it in the front? Okay, so, does everybody understand that? Give me some room down here. So, I still have x, y on this side, and then notice I have my inverse, 3/7, 2/7, 2/7, and -1/7. And I'm timesing it by 7/4. Let's go with this, because this might be on your non-calculator section. Okay? So know how to work with this, with fractions, because it might be there. Okay? 3/7 times 7. Now I understand that's 3, but I'm not going to write it that way because 2/7 times 4 is not a single digit number, right? So notice that's going to be 21/7 plus 8/7. And what did that come out to be? 29/7. Isn't that the answer we had before? Okay? 2/7 times 7 is 2, but we're going to write it as 14/7. -1/7 times 4 is -4/7. What does that come out to be? And that was our answer, wasn't it? Just another way to solve an equation. Okay? So let me ask you, if I say solve by using an augmented matrix, which one would you do? I would use the row echelon form like we did in the bell quiz. If I ask you to solve by using matrices in a matrix equation, what would you use? You'd use this method. You guys see the difference? Okay, there's another way. Like I said, I showed you already the hard way to find the inverse. That was the hard way. Okay? Let me show you the easy way to find the inverse. It is more of a plug and chug, but you have to memorize a formula. Okay, so if I had a 2 by 2, because this only works on 2 by 2s, here's the values of a 2 by 2. A, B, C, and D. So therefore, his inverse is, right here, 1 over AD minus BC times by the matrix D, A, negative B, negative C. So, why is this easier? It's a plug and chug. Okay? Why is it some people struggle with this? You got to memorize it. So, if we look at our one that we used previously, obviously we're going to use the same one because we want to make sure we get the same thing. Okay? 1, 2, 2, negative 3. Let's find its inverse. So, can anybody tell me what the A value is of our matrix? Our B, C, and our D. Does everybody understand that? Where they all correlate? So therefore, we're going to first do our 1 over our AD. What's AD for us? Minus our BC. So notice that's negative 1/7. Isn't that something nice to see? What goes here? Negative 3. What goes here? Negative 2, because we're doing the opposite of that value, correct? We're doing the opposite of that value, and then switching, so this is 1. Anybody have a question there? Is that hard so far? Can we do that? Sure we can. Okay. Notice, ladies and gentlemen, that we keep going on. Distributing through, that's 3/7, 2/7, 2/7, and negative 1/7. You notice that is the easy way to find the inverse.
Wow.
That's the two ways, guys. That's the two ways by hand that I'm showing you today. That's almost our lesson. Okay? Was that hard? Can we do that? We can do that, right? Okay. Does everything have an inverse? Even if it's a 2 by 2, does it have an inverse? Not everything has an inverse. Let me show you by that. Yes, sorry.
I was wondering, are we going to need to know how to do it both ways on the test?
Yes. So the way I'm going to explain the last way, I will ask you to find the inverse using the augmented inverse. Notice because we put it in augmented form, combined it, and we found the inverse, right? This is called finding the inverse using the determinant. Because the AD minus BC is what we call the determinant, which we're going to learn in the next lesson. Okay? So this is using the inverse to find the determinant. Okay? I will ask you both ways. Because I will. Because I want to. Okay. So, if this guy was 2, 3, 1, 6. What's its inverse? Let's do it the easy way. Well, we start with 1 over AD, which is 6. Uh-oh. We're done right there. 1 over 0. Can't divide by 0, so this does not have an inverse. Not all square matrices have inverses. Okay? All right, last but not least, we are going to our 3 by 3. We're going to solve a matrix equation using a 3 by 3. So, oops, not yet. Let's do number 4 again. Notice I'm not even looking in the book because I'm just using the ones we've already had. So number 4 of the Bell quiz. Okay, let's write this at, yes, sorry, Tristan.
So, not all square
Matrices will have an inverse because when you find the determinant might be 0, and 1 divided by 0 is the sign.
Oh.
And if you also looked at that equation, notice, look right here. If I multiply the bottom by negative 2, what do I get? 0 equals 0, right, basically? They're the same equation. It's like an infinite solutions type of a way. Does that make sense to you?
Thank you.
Yep. Okay, so using number 1, can anybody write it in matrix equation? Using number 4 as a matrix equation. Negative 1, 1, negative 1. In the matrix. Right? Am I going to make you find the inverse of a 3 by 3? No. By hand, by calculator, I will. Okay? So this is what we're going to do. We're going to find its inverse. So notice, let me show you what I would do to show my work for this type of a problem. I'm going to call this matrix A. So what do I need to times to both sides? Do I really want to put a 3 by 3 matrix there? And since I'm going to use it in my calculator, do I want to plug it in and then write it? You can to get you make sure you get the right points. Does that make sense what I'm saying? Show, because notice, using your calculator, if you don't put stuff down or what you put in your calculator, I can't help you. Does that make sense what I'm going for there? I can't give you partial. So give me somehow, some way that if accidentally you miss it by a -1 or something, I can give you some partial. Okay? Does that make sense what I'm saying on the test? Okay, if I call this A, what am I going to multiply both sides? A's inverse. Where does it have to be? In front or behind? In front. So what's left over here is X, Y, Z equals, and I call this matrix B, so I say it's A's inverse times B. That's the work I show. That's what I'm doing, and now I'm going to let my calculator do that work for me. Okay? So I go to my calculator. So I go into my matrix. Oops, okay, over to edit. And notice most of you guys already have it. We just need to change it from a 3 by 4 to a 3. Oops, we don't actually have it. 3 by 3. So I have -1, 1, -1, 2, -1, 1, 3, 2, 1. Maybe I have a question there. Yes, sir. I didn't? Oh, on the very top. Thank you. And that would obviously give me a different answer, right? Then what I do before I go on, guys, what would you do? Make sure, as he just saw, that I made a mistake. If I make a mistake, that's going to give me something different. Check it before you go on. Okay? All right, so that's matrix A. Do I want another matrix? Yeah, I do. So I go second quit, and I want to go into matrix. And this time I'm going to edit matrix B. How big was matrix B? 3 by 1. It was -14, 21, 19. Anybody have a question on how I got to that answer so far? Or where I'm at? You're looking tired. How'd you guys do over the weekend? Good. Good. Good to hear. So I go back here, and what do I want to do? It tells me right here what I want to do. What does it tell me I want to do? A's inverse times B. So, let me show you how you do it. You go and grab matrix A. The inverse button is the one right that you use the matrix. Right there. The X minus 1, that's the inverse button. Everybody see the matrix button that you would normally push? That's the inverse button. Okay? Times, and then go grab matrix B. There's your answers. So, X, Y, Z was 7, -3, 4. Solve. What if it has, though, let's talk about it. What if it has infinite solutions? Is it going to come out to be that? It's going to call it a singular matrix. By the way, so write that down. If it calls it a singular matrix, that's an infinite solutions. Do we just leave it as infinite solutions, ladies and gentlemen? So guess what I would do? I would go back to A, and I'd put it in reduced row echelon form. And then it's going to give you the equations, right? Does that make sense to everybody? And then what are you going to do? You're going to solve for Y, plug it in, and go get it, okay? Does that make sense what I'm trying to say? That's our homework. That's not bad, is it? The second most important thing is how to do that, though. Okay? All right, do you guys know that you guys do not get a review day? Okay? Just to let you know. So what I would be doing on top of this is going to the section in the back of the review of Chapter 8 and going along and doing some extra problems, or when we're getting close, come back to them and get some extra problems done. Does that make sense?
How many homeworks do I have?
We're going to have, today's 8-3, we have 8-4, 8-5, 8-6. So I see you. Let's just make sure. So 8-4 is going to be Wednesday. 8-5 is going to be Friday. 8-6 is going to be Tuesday. No offense to you guys, I don't want you to test the very first day, do you? So we're going to test right then. Okay?
On Tuesday.
Nope, on Thursday. So that's why we're not Thursday. Cade was in here, he'd shake his finger at me. Okay? Your homework, ladies and gentlemen, is 8-3, 1 through 69, every other odd. If you are planning on leaving before the end of Christmas, I will suggest you take it. 2 weeks, guys, is way too long. Just be aware, okay? All right.